On September 26, 2022, the Double Asteroid Redirection Test (DART) mission successfully crashed a spaceship into the asteroid Dimorphos. The goal of NASA's Double Asteroid Redirection Test (DART) mission was to evaluate a kinetic impactor approach for deflecting asteroids for planetary defense. According to NASA, DART collided with the tiny asteroid Dimorphos in an attempt to slightly alter the orbital speed of the moonlet. Dimorphos is not a threat to Earth, but the ambitious project simulates what NASA scientists would do if an asteroid were heading our way. The SpaceX Falcon 9 rocket carrying the DART mission lifted off from Space Launch Complex 4 at the Vandenberg Space Force Base in California at 10:20 p.m. local time on November 23, 2021. The mission exemplifies the great degree of worldwide cooperation required for such a challenging task. Scientists and engineers from all around the world have collaborated on the DART project, even though it is run by the Johns Hopkins University Applied Physics Laboratory. DART co-investigator Ellen Howell told Space.com, "We've worked really closely with our European colleagues and colleagues all over the world." Howell is a senior research scientist at the University of Arizona Lunar and Planetary Laboratory. Even though DART is a test, a similar level of international cooperation would be essential in the case of a real impact, she said. Why is the DART mission important? Even though there isn't much of a risk from asteroid impacts, we should be ready for it anyway. To demonstrate the disastrous impacts an impact can have on life on Earth, we simply need to consider previous impact events, such as the enormous Chicxulub asteroid impact that is thought to have wiped out the dinosaurs 65 million years ago. According to NASA scientists, the likelihood of a catastrophic asteroid collision on Earth is remote but real. Of the big asteroids, NASA has discovered around 40%. Additionally, NASA is creating a brand new space telescope Sentinel dubbed the Near-Earth Object Surveyor that is intended only to look for potentially dangerous asteroids around the solar system. By 2026, such a mission might be launched. Planetary defense begins with early discovery of near-Earth asteroids. Each week, 30 new near-Earth asteroids are discovered, and as of the beginning of 2019, NASA reported that there were over 19,000 discovered near-Earth asteroids. DART mission target. The Greek word Didymos, which means twin, was the focus of DART's mission. A near-Earth asteroid named Didymos and its moonlet Dimorphos, each measuring 525 feet, 160 meters, are the components of the system. Didymos is 0.48 miles, 780 meters, across. At 4.1 miles per hour, 6.6 kilometers per hour, DART intentionally collided with the moonlet Dimorphos. At 14,760 miles per hour, that is staggering. This impact speed should affect the moonlet's orbital speed by a tiny percentage, which should be sufficient to change its orbital period by a few minutes. NASA states that telescopes on Earth will monitor and measure the shift in Dimorphos' orbit around Didymos to determine whether the mission was successful. DART's journey to Dimorphos. DART was a straightforward spacecraft. The main vehicle's dimensions, as reported by Jupil, were around 3.9 by 4.3 by 4.3 feet, or about the size of a refrigerator. When completely extended, the two substantial solar panels each measured 27.9 feet in length. Didymos' reconnaissance and asteroid camera for optical navigation was the sole instrument aboard the DART mission, Draco. It turns out you don't need to bring anything with you if your main objective is to collide with an asteroid. The rollout solar arrays, ROSA, were deployed by the DART spacecraft after it was sent into orbit by a SpaceX Falcon 9 rocket. According to NASA, scientists evaluated the ROSA arrays when they were housed inside the International Space Station in June 2017 and found them to be capable of supplying the necessary power to run DART's electric propulsion system. The power grid of the space station now includes larger ROSA arrays thanks to NASA. A further component of the DART spacecraft's in-space propulsion was the next-generation, fuel-efficient NASA Evolutional Xenon Thruster Commercial (NEXT-C) solar electric propulsion system. DART asteroid impact. The first planetary defense test ever was carried out by DART on September 26 at 7:14 p.m. Eastern Daylight Time. At the DART Mission Control Facility at Jupil, there was a mixture of calm and suspense as the spacecraft rushed towards its demise, despite the on-target crash. Engineers didn't need to test any of the 21 potential backup plans they had developed in case the crash didn't go as planned. The remaining 4 hours of DART's journey were largely automated, and in the penultimate hour of its approach, the spacecraft's navigation system locked onto Dimorphos. As the spacecraft collided with the asteroid, DART's main camera continued to send images to Earth every second until the feed went dark. Stunning features of Didymos and Dimorphos were captured in images taken by DART during its closing moments. Never previously had anyone seen the moonlet. It was a bizarre new world, an egg-shaped asteroid with a rocky surface that was discovered by DART. DART's companion, Lycia Cube. Apparently, LICIA Cube traveled with the DART spacecraft on its trip to the near-Earth asteroid pair, as reported by NASA. The Italian Space Agency and Argotec in Italy collaborated to create the CubeSat known as LICIA Cube. The tiny CubeSat, which weighs about 31 pounds, 14 kilograms, is about the size of an adult's hand and forearm. It has 2 optical cameras installed and trailed DART towards Dimorphos before settling in to observe the crash from a safe distance of around 600 kilometers away. The role of LICIA Cube was to observe the impact to help confirm whether the experiment has worked. All eyes are on DART. Other spacecraft joined LICIA Cube in watching the DART asteroid collision, including NASA's new James Webb Space Telescope, the Hubble Space Telescope, and the Lucy spacecraft on its own asteroid mission. All of these spacecraft watched the collision from their respective vantage points throughout the solar system. They are now poised to observe the pair over 6 months to investigate how much faster Dimorphos is now moving in its orbit and whether the redirection test has been successful. What happens next? The Hera mission is a post-impact inquiry being planned by the European Space Agency, ESA. According to the mission website, the spacecraft will be launched in October 2024 and will arrive at the Didymos binary system in December 2026. Though the 2 missions, DART and Hera, are created and run separately, when combined they will improve our knowledge of planetary defense technology. IDA, Asteroid Impact and Deflection Assessment, is a global partnership that includes team members from both missions. IDA, according to ESA, is a significant international partnership between ESA, the German Aerospace Center, DLR, the Observatoire de la Côte d'Azur, OCA, NASA, and the Johns Hopkins University Applied Physics Laboratory, JUPL. According to Chabot, DART is only a small component of a bigger planetary defense plan that is coordinated by NASA's Planetary Defense Coordination Office. Future planetary defense initiatives will be greatly influenced by DART's demonstration of this technology, she said. The success of any future planetary defense mitigation initiatives, of which DART is merely the first test, depends critically on locating, tracking, and characterizing the population of near-Earth objects. If you liked the video, smash the like button and subscribe to the channel.